Omar, what are your questions?
I'll take pre-cal.
I don't know how to explain my question.
We're not asking about pre-cal, we're talking about our algebra 2 right now. What's your question, Omar?
Oh.
I don't know.
Okay. Do you understand the question up here of explain why the product of the linear factors results in g of x being positive?
Oh, this go on there. Okay.
First off, do you understand that g of x, the
Yeah.
outputs are positive? Okay? What are the, by the way, what are the ways to create a positive number when multiplying?
Negative.
A negative times a negative or a positive times a positive. Look at these outputs. This has what kind of outputs? Negative. This has negative. And what's a negative times a negative? That's why these are positives. That's it. The two linear factors have negative values. A negative times a negative creates a positive. Really, I should say negative output values. If that wasn't clear already, make sure you add that output there. Okay, so I want to make sure that this is clear by looking at the question 2. Question 2 says, consider the interval between x equals -3, that's this first purple vertical line, and x equals 0. Explain why the product of the linear factors results in g of x being negative. So here's g of x. Let's just start with why g of x is negative. Omar, can you tell us why g of x is negative, or how we know g of x is negative?
Point, maybe?
What part of the points are negative?
Right there. Like, where you plot it right there. Would be negative.
But remember, a point has both an x and a y, so when we say that g of x is negative, what do we mean by that? Are we talking about the x, the y, or both?
Both.
No.
Why?
I need
G
you
of
to pause.
X is just like f of x. Why?
So remember, and I say it that way because I need you to pay attention, Omar. G of x, we've said this a few times, that is my set of outputs or y values. So when I talk about g of x specifically, I'm talking about the y. That's it. Kelsey, can you tell us why, looking here, we know that g of x is negative?
Because it's on a negative graph.
What do you mean by that?
It's below 0.
There we go. Remember, this x-axis is where y is equal to 0. We're below 0. Just talking about the y, it's below 0. So it's negative. What are your questions?
I don't know.
Glad you don't.
None.
Anybody else?
That purple line.
Which one? There's a few now. Huh?
The vertex, you know what I'm trying to say.
This curve down here?
Yeah, that's G of X. Isn't it?
So the parabola, remember, was g of x. So I didn't highlight the entire thing, I just did this for number 1 and this for number 2.
Okay.
So I want us to notice, it asks us to look at the linear factors. Why is g of x negative? Looking at the linear factors, huh? Well, that's looking at g of x, but now it's asking us to explain why the product of the linear factors results in g of x being negative. How can we create a negative number when we have factors? Multiply a positive and a negative. Okay? Those numbers are what? Positive. Remember, that's my x plus 3. These numbers are, and that's my y equals x. What's a positive times a negative? Negative. Right? So why is g of x negative, right? So g of x is negative because y equals x plus 3 is what?
Positive.
Okay, y of x equals x plus 3 has positive values, but y equals x has negative values, right? Notice how it's below 0, right? Y always below 0, so y equals x has negative values. A positive times a negative creates negatives. That's why.
What we writing down, Mr. King?
Hmm?
What we writing down? I'm saying what you writing.
I'm about to talk about it while people, I'm writing this up here
Oh,
while people are finishing that.
oh, okay, okay.
Ms. Courtney, I'm about to be done if you wanna get ready for your section.
Can I look at this real quick?
Alright. So the last part of 4b, and we do want to notice this, it says, explain why the product of the linear factors results in g of x being negative. We already did that. Why and why the function changes from decreasing to increasing. So I've already started this. The change from a domain interval of decrease to increase because of what? What is where we see that change in decrease to the change in increase? So, in between here, we see the function change from decreasing to increasing. What's causing that?
The parabola? 2x himself.
No.
Well, what was your question?
Okay, so hold on to that for 1 second. The question, just to make sure everyone's clear on this, is, right here it says, explain why the function changes from decreasing to increasing. So what do we see in this interval that's causing the function to stop decreasing and start to increase? And what do you say on it? The vertex? Is that vertex where it stops decreasing and starts to increase?
Yeah.
So we want to pay attention, is that vertex, that maximum or minimum is where we change from increasing to decreasing, or vice versa. So changing from domain interval decrease to increase because of the vertex. It's the last thing we want to write there.
Can you gonna change our seat? When we get back from break?
I'm ready, yeah.
Put me up there. That was.
Oh my.
Alright. Need to erase and get the next thing up there.
They ready?
What's your call? What are you on about?
Huh?
What are you on about?
Huh?
What are you on about?
His eyes. But up under his eyes, irritating. No, I still be learning.
Okay, guys, so, what we're gonna be doing now is we're gonna start this activity that's building right off of, the new concepts you were just practicing, so like dilating a function by a non-constant function, and like creating something new. But like I created this so you can, in your groups, you're gonna be choosing, you kind of have some choice to the types of functions you're using, and so each group's gonna have essentially a slightly different product, like we're gonna be graphing. But the concepts and the ideas of these intervals of, like our domain intervals and like where this graph is, or where your parabola and stuff is like that's positive, we'll still be able to talk about that. So, our first part is, as a group, create a linear function with a negative non-integer slope and graph it. So let's think about that for a second. I want you guys to take 30 seconds in your group, maybe a minute. Think about what do we mean by a negative non-integer slope. So,
What is that, Miss Courtney?
so once you, okay, so well, what's a slope?
The
Rise, right. So, okay, so in your groups, talk about what we mean by negative non-integer. So maybe come up with a few examples.
Like -2, 3?
Right, so what do we mean by integers?
A whole number.
Essentially, whole numbers and integers are slightly different, but we just mean not, like fractions, I guess. So, but, okay, 60 seconds in your group, you guys talk about it and come up with some examples.
What?
And,
Y'all know the energy?
Y'all,
Also.
positive or negative whole numbers. Miss Courtney just explained it. Y'all are not even trying. -3, -2, -1, 0, 1, 2, 3. Those are integers. So we want something that's not an integer. Is that clear? Decimals or fractions, that works. I'm sorry, I'm frustrated by the lack of effort at times because we just want to act like we have no clue what's going on instead of putting our brains in gear.
I will say though, but so since we're gonna be graphing this by hand on paper, you probably want to work with a slope that's not in decimal form so you can count like that rise and run. So think about slopes that fit that criteria. Okay, so talk in your groups and then I'm gonna call on people to give me some examples so we can continue.
We do a decimal.
As a group, create a linear function. Alright, so we're doing 3 plus 6, then 1.5. So then we do 1.5 or like 9.5.
So you want it to be negative and you want it to be not negative. So what would that look like? Okay, so does that fit the criteria?
Yeah.
Okay, so can you guys come up with maybe a few more examples that would also work in this case?
Okay.
So what's, so you guys? Okay.
I'm just doing it.
So that works.
Is it negative? Is it non-integer? Does it fit that criteria? Okay.
When you graph that, when you.
So is it?
No, you're coming up with a slope.
If it was your
I don't know, don't.
would it be like?
This, we're not gonna graph from this. I don't know what.
If you graph it,
So it can't be a decimal.
you just graph.
Well, I mean, I'm sorry. We wanna keep it as a fraction because we're gonna be graphing it on here. So you wanna be able to count like your rides or the runs.
Start making ourselves a fraction.
Yes, but make sure, but also you wanna make sure that
No, on the graph.
you come up with something that's negative. Yeah.
Gosh, wherever it be.
Okay, guys, so, okay, so, I heard some of you giving some ideas out, so let's talk about them. Jenny, what is, a slope that your group came up with? You can tell me any of them, I know y'all had it with you. Okay, so -1/2. It's negative, is that a non-integer value?
Yes.
So does that fit our criteria for what we're looking for?
Yes.
Okay, so that's a valid, I'm just gonna write out here like possible slope. So when it says create a linear function with a negative non-integer slope, how can we use that slope to write it in the form of a linear function? Because if I just write,
Down 1/2.
well, what do I mean when I say a linear function?
Y equals mx plus b.
Okay, so if we're talking about y equals mx plus b, and she gave me a possible slope of
You'll put it right here.
-1/2, what part, where does this go?
What again be?
Okay,
Y equals -1/2 x plus b.
so I'm just gonna keep it as -1/2 x because,
We don't know what B is.
well, true, but so we're gonna be graphing these, so, well, hold on, let's keep talking about some more. Kyle, what's a slope that you guys came up with, or a linear function that you guys came up with?
Slope -5
-5 divided by 7, okay. Sharnadia, what about your group?
-2 divided by 3.
Okay, -2 divided by 3. Let's get one more. Eli, what's one slope your group came up with, or one linear function your group came up with?
-3 divided by 5.
Okay, so these are all all examples of linear functions that have a slope that fit that criteria. So now in your groups, I want you guys to do number 1 and number 2. Okay, in your groups for number 1, your group will decide on one of these to graph as a whole. Okay, do you understand what I mean by that?
Yeah.
Okay, so like this group, if you guys all came up with this negative non-integer slope, you should all be graphing the same line. Okay, because that's how we're going to talk about these discussion questions later on. So that's for number 1, and then number 2, what is it? What line are you going to graph?
The linear.
What line?
Huh?
What does it tell you to graph in number 2?
G of X equals X.
Okay, so what slope is that? What?
It'd be a straight line.
Right, so it would be a line with a slope of what?
0.
What?
What do y'all think? What's the slope of this linear function, guys?
1/1.
Okay. And also, what's the y-intercept of this linear function?
0.
Okay, so do you guys understand how you'll be graphing this line on your paper?
Yeah, it'll be like this. Zero.
Okay. Do you understand what you're supposed to be doing right now? Graphing 1 and 2 on your paper,
Also,
on this graph.
you can make a table, did you want them to have a y-intercept other than 0? I think it would help with
Yeah.
this lesson.
So for like this one,
Yeah, if
so
you
when you're
choose,
creating your own, for number 1, you have a y-intercept of, do you want to give them like a range of values to choose from for that? I didn't think
so
about that.
you need a multiple of the denominator, no. A multiple of the numerator would be my suggestion. Yeah. Which that might sound bizarre, but you need a multiple of the numerator. So whichever slope you choose, you need a multiple of the numerator as your y-intercept. So for negative 2/3, you could use 2, 4, 6, 8, negative 2, negative 4, whatever. It just needs to be a multiple of that numerator.
Yeah, so I'm gonna write that note on the board so we have that. But since we have 5 minutes left of class, I want you guys to really focus on getting these lines, these linear functions on your graph. So Monday when we come back, we're gonna dilate them. Okay, kind of like how we looked at in that textbook problems. Say that again.
Would that be G-Vex?
Let's use
Yes,
five.
and yeah.
Oh, this is that.
So is that your g of x equals x?
So what's that?
Would it be?
Y-intercept?
Yeah, positive 1.
Our y-intercept would be negative 1, because we doing negative 1 half.
It just has to be a multiple of negative 1.
Okay. It
So,
should be a multiple
1,
of
2, 3, 4, 5, or
the-
negative 1, negative 2, negative 3, negative 4.
Alright,
Any multiple of 1.
we're gonna do negative 4. We're gonna do our y-intercept.
Yeah, he's doing
Yes.
0 right now.
Sorry. Okay. Do what? So it just needs to be negative. The slope.
We just do it like this.
Yes.
He said you need a multiple of the numerator, meaning, I'll say like 5.
Well, so if it's negative, it's actually gonna have to go the other way now. Because of that slope. So graph 3 and then down 1 over 2. Yeah.
I went ahead and did the.
So you wanna graph both of them together.
How would you do it?
Yeah, but make sure the y-intercept first.
So the g of x, that's what?
Negative 4, negative 4.
So this is still a linear function.
Negative 2.
I know it's like,
Yeah. But
So we
make
can
sure
also
they line
write it
up.
like that. So that's a line, you know how to graph that line.
Then your
Alright.
x, your x.
Wait, does yours go over this one?
Well, what's the
I
y-intercept
have
of that?
I have a solid question though.
Okay, and then what's the slope of that line?
So,
No.
when you
Okay,
have
so
the
think
negative
so right here.
slope, and you get
What
odd by
does
negative
slope
5
mean?
divided by 7. Is the whole fraction
Down
negative?
5.
No, I know
I'm
that,
saying
I'm asking
to
to
the
the,
right
would the whole,
side.
would the whole fraction be negative, or would just the numerator be negative?
If this has a
The
slope
whole
of
fraction is
negative,
Ours is supposed to be
negative,
negative.
meaning that either the numerator or the denominator is negative, and the
went
other one's
down 3
positive.
over 4.
Because positive
Okay, so
divided
if I
by
have a slope of
negative
1,
is negative.
where are you gonna go?
It's straight now.
What if I wanted to,
Now.
Oh, wait,
wait,
not
down.
so both of the,
Up 1 and then to the right of
so the numerator and denominator can't both be negative?
It's not 0. Right.
Negative 2 divided by 3, 2 divided by negative
Right.
3,
Yes,
and negative 2/3 are all the same. If you have negative 2 divided
Right,
by
because it's
negative 3,
positive
that's
slope.
a positive.
So,
Negative divided by negative is positive. Wait, hold on.
Ours is
What
supposed to
equation did you
be-
use?
Ours is supposed to be through negative
well,
5.
think about if g of x equals
What's your
x,
y-intercept?
what's g of x?
Why?
No,
Okay, so-
y-intercept.
So what's that
Oh,
equation?
okay.
Y-intercept.
Y equals x.
I put something under
Okay, so what's that line look like on
When
the
is it be
graph?
negative 5?
So,
What's the slope of that line?
what is this, 5 right?
1 on 1.
So doesn't it need to be increasing?
And you still go down 5.
Right, so but how much are you gonna go up and over? Up
Mr.
one.
King, do you have like
Huh?
What's your y intercept?
How we did it?
Do what? So this one, yeah, we can do it. So this has.
All right, we will finish up on Monday. This is your practice assignments that you should probably pay attention to. This will probably be due on Tuesday. You cannot do this yet. So you can't do this yet. But be aware, you might want to take a picture or just walk out. Oh, I told you about the collect. I need y'all's practice assignments.
I did it, so I'm.
Yeah. If I don't have it,
We'll
it's
talk about it.
late.
We'll come back, we'll revisit this
Huh?
Monday.
I did it.
Hey, y'all.
Please your test register came from tutoring. Okay, I'll look over this weekend then.
They won't mind.
Guys, I need your homework before you leave. Or it is late.
please up?
Huh?
The rulers?
Yeah, you can just leave them on the desk.
Yeah. No, today, you're good. Thank you.
I think mine's just.
Oh, you need to.
Yeah. Put all of them together?
Yes, sir.
Yeah.
That's why you go out to working class. You wouldn't have to do no homework. That's all right. Well, I told her. Here you go, Mr. King.
Thank you.
You did a whole bunch of stuff.
So can you put that slide back up with the homework?
I said, I was sorry.
I do.
Huh? I'm about to scan it with mine.
Oh,
Just get on behind.
I said, I don't know, I gotta come back and.
You didn't ever read yourself? Sir,
My pencil has been slow.
say that one more time?
My pencil has been slow. Just like my face.
Has what?
Been slow.
There's some short ones up there if you need it.
Oh, no.
So you gonna be in the